So in this presentation, we're just going to have a look at directional control valve, typical of a skid steer, and I'm using Bobcat as an example here. So we're going to have a look at the Bobcat skid steer loader. So we're just looking at an animation here of the component layout. So we've got a reservoir holding some oil. We've got a what looks like to be a vane pump on this particular model of machine, maybe an older Bobcat skid steer. And just for reference, of course, what we're looking at is a machine like this, typical small, compact skid steer loader that would be hydrostatically driven, and then would have a typically a 3-function control valve for the hydraulics, for lift, tilt, and auxiliary functions. So lift operating the 2 lift cylinders, one on each side of the machine here. Tilt operating, in this picture we've got 2 parallel tilt cylinders, but some smaller Bobcats will only have a single tilt cylinder. And then we've got quick couplers for auxiliaries here. And there may also be rear-mounted quick couplers for a second set of auxiliaries on the back. And I'm just mentioning that because this animation seems to show two auxiliary functions. Well, they don't in the animated, but when they get to the schematic, they show us 2 auxiliary functions for whatever reason. But so again, we've got oil flowing from the reservoir through the pump to an open center control valve. Because this is a positive displacement pump, whether it be a gear pump as it is on some skid steer loaders or a vane pump like they're showing here. Those are positive displacement pumps, so they've got to put out flow anytime the engine's running. So an open center control valve is going to let that oil go right through. And then it's, in this case, returning through a oil cooler, big aluminum radiator type oil cooler that the fan can blow the heat out of, sharing the fan with the engine radiator, and then making the stack. So generally there's a couple of different radiators back there stacked together. And then we've got the return oil filter, which appears to be a spin-on element, a full flow cartridge type filter. Full flow because all of the returning oil is going through that filter. So 100% of return flow is filtered. Wouldn't be a high efficiency filter, probably 30 or 40 microns. And then back to the reservoir, although you'll see on some compact machines like a skid steer, the engineers take a little bit of license here to make some compromises. And instead of forcing the oil back into the tank at one point and drawing it out at another point, they've simply teed this connection so the oil has the option of going into the tank, or it can go directly back to the suction of the pump. A lot of machines, they wouldn't do that. They want the oil to spend some time in the reservoir for cooling. But on this machine, this tank is a very small plastic tank. It wouldn't do much cooling anyways. And to compensate for that, they've oversized the radiator type cooler. So they can just send the oil, in this case, back to the suction side of the pump. Not many machines are going to do that, though. Certainly an excavator or a larger machine is going to put the oil into the tank. So this is basically what happens when you start the machine. And the pump is circulating the oil. The operator is using no functions here, so the open center flow path is where the oil is going through the directional control valve. What isn't shown here is a main relief valve. So they've left it out of this animation, but the relief valve would be near the inlet here on the main directional control valve block, somewhere perpendicular to where the oil is coming in here. We'd likely have the main relief valve in this area. Then we appear to be crossing 3 valves, lift, tilt, and auxiliary. And in this animation, there's actually a faux pas here. They've connected I don't like the way they've connected the lines to this particular cylinder. I'm not sure which cylinder this would be. I guess it's supposed to be a lift cylinder. Why there's only one, I'm not sure. And why they've connected it across 2 different spools doesn't make any sense. But we'll forgive them because the rest of the animation here is good. But just be aware that's kind of a mistake. So just going around the components again. So we've got one particular cylinder here for just to represent the function of a cylinder. We're going to tie that to the reservoir here in a second. So there's the cylinder extending. Just going to pause this again. So if you had a keen eye there, you may have noticed while the cylinder was extending, the reservoir level was going down, and now we show arrows coming out of the reservoir. So while the cylinder is extending, because it's unbalanced, it's got a larger volume on the base end or head end of the cylinder here versus the rod end. So a double-acting unbalanced cylinder, most common type on heavy equipment. As it's extending, it's going to require more oil than it's returning back to the system. So that's where the reservoir comes in. The level goes down as oil is needed to make up for that imbalance in the cylinder. So more red oil went in than blue oil came out. So they're using red here to show system pressure. They're using blue to indicate return flow. And the animation didn't really correctly show the flow there, but we'll get to that. It's coming from the pump, obviously going across the spool now into the base end or head end. Oil's returning from the rod end, in this case back into the open center flow path, back through the cooler filter, and back to either the tank or the suction of the pump. And as we retract that, if we move the spool the other way, retract the cylinder, now the oil reservoir has to fill because we've got more oil coming out of the cylinder as it's retracting than is being put in from the pump. So that was an animated sort of review of that concept. Here's how things look schematically. They've changed the machine here slightly, but it's very similar. They've got a reservoir, pump, control valve, lift cylinders. Now they've showed 2 lift cylinders, a single tilt cylinder, cooler, filter, and there's the open center flow path through the directional control valves. So there is, in ISO schematics, we're using rectangles to show control valves, and we're using a certain type of line here to show the enclosure around a control valve. So this is a monoblock or one-piece casting of this control valve. So that's the type of line they use to show an enclosure. Basically long, short, long, short. Sometimes you'll see long and 2 short dashes, but that is indicating, different from all the other lines on this drawing, that's indicating an enclosure. So everything inside this box is part of the main directional control valve. So again, we've got oil entering. We've got this would be a hose connection to the directional control valve here. So pump flow connecting to the DCV. We've got a connection here where oil is leaving the DCV, going to the cooler, filter, and back to tank. And then we've got an open center flow path straight through across all of the control valves when they're in the neutral or hold position. So if the operator's doing no work, just engine's running, the pump is turning, then we've got this open center flow path. Also got now the main relief valve indicated here. So I know this is the main relief valve because of its location. It's in the directional control valve and it's perpendicular or 90 degrees to where the oil is entering the valve. So that's where on any schematic you're basically going to find the system main relief valve. So main relief valve is normally closed. It doesn't pass oil until the pressure builds up here to overcome this spring which is holding it closed. And at the value that the engineers have determined is the maximum this machine should operate at, that relief valve then could open. And if oil opens that relief valve under high pressure, it's going to push that arrow over into alignment, connect this passage to this passage, and then oil is going to flow out around all the control valve spools and connect to the same return that oil normally would exit the valve and continue to be cooled and filtered. So when the relief is open on this machine, we're still cooling and filtering the oil. Which is good because the relief valve tends to generate a lot of heat. For some reason, they didn't show the arrow through the spring here to show that that relief valve is adjustable. However, it is on most skid steers. It doesn't require shimming. It's usually screw adjustable. Again, for some reason on this valve, they're showing 4 spools, not typical of most Bobcat skid steer loaders I've dealt with, but we see foot pedal operation here. So this symbol on the bottom of the lift spool is indicating it's foot operated. And then we've got basically 4 positions to this valve. There's 4 boxes that make up this long rectangle for the spool valve, and they indicate the different functionality of the valve. Right now we're using this box, which would be defined by this line to this line, and that is our hold or neutral position. There's a centering spring here, so when you take your foot off of the pedal, the valve will be centered to this position, so to the hold or neutral position that we're shown in right now. And then we would have a lift and a lower position, and then here there's also going to be a float position. And there's a detent indicated on this end of the valve, this kind of roller and notches symbol that's on the end of the spool valve next to the centering spring is indicating that there is a detent, and that detent would be what's going to hold the lift control valve into the float position, or the float detent. And then the work ports, so we've got a line coming into the valve, we've got another line coming in through this check valve, that's our load check, and then we've got 2 work port lines leaving the valve here and here, and they connect down to the lift cylinder. So this line coming out here connects down to, tees off here and goes to both ends, both head ends of the 2 lift cylinders. And I'll come back to this valve in a second. And then we've got this port coming out, feeding oil down to, again, teeing off and going to the 2 rod ends of the lift cylinder. So the cylinders work in parallel. This component I skipped over en route to the head end of the lift cylinders is a one-way flow restrictor. When oil exits the valve here and goes to the head end of the lift cylinders, it takes a 90-degree turn here, goes over to this check valve, opens the check valve, and goes around this orifice. So what that does is when you're lifting the loader frame, putting oil into the base end of the lift cylinders, it can open this check valve and free flow unrestricted to the lift cylinders. But when you're lowering the loader frame, oil returning from the lift cylinders as it comes back here is going to hit that check valve and shut it, lock it shut, and then the oil returning is going to have to travel through this restriction or orifice. So that symbol is representing the restriction of the one-way flow restrictor. And then it travels through there, then back across the valve, back to tank when we're lowering the loader frame. That's common on a skid steer loader that is on rubber tires, because they're fairly tippy machines. They don't want the operator lowering the loader frame too quickly and then stopping. What that can do is have the machine rock forward on the front tires and tip the machine, and you've got an operator hanging in the seat belt, not in control of the machine. If the machine's on tracks, then you may not have a one-way flow restrictor, because the machine's got a more stable platform that it's working on. It's not going to be rocking so much on the on its undercarriage. Also in line with this port, we went down to the cylinders, but if we go up, we'll see that there's another relief valve here. That is our port relief for the head end of the lift function. So there is a dedicated relief valve to that particular work port. That's going to protect the machine from pressure spikes when we're not using the lift function. And then we've got a port relief, or sorry, an anti-cavitation check valve over here. So lots of check valve symbols. We've got load checks here. We've got anti-cavitation check valve here. Another anti-cavitation check valve here. And then we've got lift, tilt, and 2 auxiliary functions. We must have front and rear mounted auxiliaries. What doesn't really make sense on this drawing is they're showing hand operation, manual operation for the auxiliaries, when on Bobcat skid steers they're typically electro-hydraulically actuated, but I guess they're just trying to simplify this for us. So that's a basic overview. We'll come back and look at some functionality in the next clip.